Hi friends, in this video we are going to take a look at the integral of root of tan x dx. Let's see how we can go about this. Now, what method can we use? I think we should make use of our substitution method. Use sub. Let's say let u equals to root of what? Of tan x, right? So that du will be equals to, no, I think we should square both sides first. Let's square both sides to eliminate this. Squaring both sides, we have u squared equals to what? Tan x. I think we can now differentiate both sides. Differentiating this, we have what? 2u du equals to what? Differentiating this, we have what? Sec square x dx. Okay, what other thing can we do here? We can actually make the x the surrogate of what? Of the relation, right? Okay, let's divide both sides by what? Sec square x. Divide both sides by what? By sec square x. Such that we are having the x equals to 2u du over sec square x. Very interesting. Okay. Let's fit everything back to its position. So you're having integral of what? Of u times what's that? The x, that's 2u du over sec square x. It's okay. Show that this can be what? Can be integral of 2u square, right, over sec square x du. Okay. But here we are going to do a little trig identity here. We can recall from our trigonometric identity that our sec square x is also the same thing as 1 plus tan square x. Okay. Let's fill this back. We are having integral of what? Of 2u square divided by 1 plus tan square x du. But if we take a look at this very well, we cannot integrate because we are having the what? The value of x here is supposed to be in uniform, like that is supposed to have something like u here in order for us to integrate. Okay, what others can we do? Okay, we are having tan square x here, but here we are having tan x. Can we square both sides? Let's square this side again. If we square if we square this side, we have what? U raised power 4 equals to what? Tan square x, right? Perfect. You can easily replace this with what? With u raised power 4. So that this integral is the same thing as integral of 2u squared divided by 1 plus u to the 4 power du, right? Okay, everything is now good. So what other thing can I do here? I cannot do my u sub, okay? I cannot do anything. I cannot use u sub again. Let me choose to divide all through by u squared. If I divide all through by u squared, let's say we are having, dividing this by u squared, we are having 2, right? Divided by 1 over u squared plus this one will reduce by what? By 2. That will be u raised power 2 du. Wow, perfect. But if you look at this very well, this particular algebra function here is also the same thing as writing like, okay, let's look at this 1 over u all square, right? If you expand this, we are having, that will be u squared plus u over u, right, plus u over u plus 1 over u squared, right? So that this we cancel this, we have, okay, everything here, that's what? That's 2 plus 1 over u squared plus what? Plus u squared. So let's bring this to this side. We are having u plus 1 over u all square minus 2 equals what? U square plus 1 over u square. Can you see it now? Bravo. So we can easily replace everything here with what? With this. Can you see it now? We can replace it with this. So let's see what we can do. We are having integral of 2 over u plus 1 over u all square minus 2 du, right? So what others can I do here? Okay, let me try to split it. Okay, what if I try to split it? Okay, let's split it like this. We're having integral of 1 here over u plus 1 over u all square minus 2, right? Plus integral, I'm going to add 1 here, right? 1 over, if I had 1 here, so here I will have u minus 1 over u all square plus 2. That's what I will have, right? I think. Okay, let me choose to add, let me subtract 1 over u square here so that it will be balanced and look, say, okay. If I subtract it from here, that means I should be adding it here. That will be plus 1 over u square. Okay, wow. Yeah, it's good like that. Okay. What else can I do here? What can I do? Okay. Yeah. Let me do u sub. Let's take u plus 1 over u to be our p. Similarly, for this, we are having u minus 1 over u to be our, that will be, let's use L. Yeah, to be better. Yeah, let's do L. So here, if my dp will be what? My dp, if I differentiate this, that's 1 minus 1 over u square du. Yeah, if I differentiate it. So, differentiated my dl here, that will be what? 1 plus 1 over u square d, okay? Yeah. This is my dp and this is my dl. Show that here, I can easily rewrite it like this. Integral of 1 minus 1 over u square divided by what? My u plus 1 over u all square minus 2 plus integral of 1 plus 1 over u square divided by u minus 1 over u all square plus 2, right? So I'm having my what? My dp to be 1 minus 1 over u square and my dl to be 1 plus 1 over u square. Wow. If you take a look at this thing very well, on top, we're having 1 minus 1 over u square. Here, it's still the same thing as what? As my dp. My dp is equals to 1 minus 1 over u square. Here, I can change it. I can represent everything here as what? As integral of what? Of dp over. So here, if you take a look at this place, we know that our p equals what? U plus 1 over u. Can you see it now? So it's still the same thing as this, u plus 1 over u. So we can easily represent this as our p. That would be dp over p squared minus 2, right? Plus integral of 1 plus 1 over u squared is still the same thing as what? As dl. All divided by, we know that our u minus 1 over u, which is this, is also the same thing as what? L. So this will simply be what? L squared plus 2. Now, we are almost there. Can you see it now? Very simple. So what else can I do here? Yeah, you are right. We are going to do our, we are going to use our this completely discrete method. Yeah, our tan, and also we cover everything up. Yeah. So there is identity for this, and also there is identity for here, for this, right? The identity for this one is the same thing as minus 1 over a tan inverse of what? Of p. Let me use x over a. If you recall, this is. Can you see that? Similarly, the identity for this is also what? That's 1 over a tan inverse of what? X over a plus c. So the identity for this is this, and the identity for this is also this. So here we can easily what? You can easily take our p to be x and our 2 to be a. But this time around, I can write my 2 as root of 2 all square, right? If I write it as root of 2 all square, it's still the same as 2 because this square will cancel this. So I'm having my 2. So here I will just have something like minus 1 over root 2 tan inverse of what? What's my x? That's p over root 2 plus 1 over root 2 tan inverse of what? What's my x? That will be what? That will be L over root 2 plus C. Is this the final answer? No. Why? Because my L is taken to be what? Is taken to be U minus 1 over U. And also my P is taken to be what? U plus 1 over U. Then I can easily replace everything here with this. Let me put them back into the solution. So that I will be having minus 1 over root 2 tan inverse of what? Of what's my P now? That will be U plus 1 over U over root 2 plus 1 over root 2 tan inverse of what? Of U minus 1 over U divided by root 2 plus C. Okay. Am I going to leave my answer like this? No. What else can I do? Yeah, I have a lot to do because if I recall from here, I said let my U to be what? Root of tan x. So I should fix the problem here because I'm having it in terms of what? Of U, not in terms of what? Of x. So I need to return everything back to x term. So I'm having minus 1 divided by what? Root of what? Of 2 tan inverse of what? Of what's my U now? My U sticks to be what? Root of tan x plus 1 over root of tan x over root 2 plus 1 over root 2 tan inverse of root tan x minus 1 over root tan x over root 2 plus C. Right? So here, this is my final answer. But if I look at 1 over root of tan x, 1 over tan x is still the same thing as what? As cot x. Yeah. So I can easily write everything if I recall that my 1 over tan x is also the same thing as what? As cot x. Then let me put cot x here. So I'm having minus 1 over root 2 tan inverse of root of tan x, right? Plus, that will be root of cot x, very good, all divided by root 2, plus 1 over root 2 tan inverse of what? Root of tan x minus root of cot x divided by root 2 plus what? Plus my arbitrary constant. So this is the final answer. Thanks for watching.